Right, good afternoon everybody, and welcome to the Ethereum part of today's show. I've heard there was a lot of curiosity about Ethereum and a lot of people speculating on how Ethereum would play into the whole redecentralized kind of landscape. So what I wanted to give was kind of cultural history of the crypto that led to Ethereum, to really talk about how things progressed from the first kind of early cypherpunk days through to the present, and how that kind of cultural history affects how Ethereum relates to the other projects in the space, and how all this stuff interconnects into some kind of real change. Does that sound like a reasonable thing to spend a bit of time on? Okay, so is anybody here old enough to remember PGP being released? A couple of hands. So for the rest of you, encryption has always been available, even if it's been impossible to use. But
It still is.
is that working? Okay, great. So, so back in the day, right, there was no civilian cryptography available that you had any degree of trust in. Right? There were expensive systems that were used by governments. There were expensive systems that were used by companies. But it was the middle of the Cold War. The Berlin Wall hadn't come down until, what, 91? And, the entire field was filled with fear, loathing, secrecy, and lies. Cryptography was military stuff. We'd used breaking crypto to win World War II, and the whole thing was surrounded by kind of fear, uncertainty, doubt, numinosity, spooks. It was just a right mess. And the majority of the cryptography that was available, but all the cryptography that's publicly available, was symmetric key. And symmetric key cryptography hasn't changed very much since it was invented, right? You go back to things like Caesar ciphers. You have a single key which allows you to encode a message, and a single key that lets you decode a message, and they're the same key. So what you require to be able to talk to somebody using sort of one key cryptography is you need the ability to have a secret communication channel with that person, and then you take your pre-existing secret communication channel and you load a whole bunch of additional information into that channel. So the only organizations that can effectively deploy this kind of cryptography are the organizations which already have secret communications between their people. Does that sound like us? No, right? This is the work of spy agencies. Having secret communication channels and self-structured organizations and all the rest of these kind of things was, the reach of these organizations was empowered by the availability of one key cryptography. But if you weren't an organization that already had that kind of feature, there wasn't very much you could do with it. And the fact that if somebody was captured, you got hold of their keys and then you could decrypt all of the messages that had been sent to them previous to that, highly problematic. So what comes into this kind of situation is that there was no change in the distribution of power simply because you had a new kind of cryptography. The new kind of cryptography was only useful to the existing players, and as a result, very little changed, even though symmetric key became kind of common around the time that AES was invented, which is probably mid-1970s for AES? Maybe a little bit later. AES, Advanced Encryption Standard. So, or actually DES. Move forward. So then we get the whole sort of symmetric key thing. So most of us, again, if you're younger, you're going to assume that we've always had symmetric key cryptography because it's been around since before you were born. And we're old enough now that you could get real hackers that were born post symmetric key coming out. But actually, back in the day, it was an enormous shift in perspective for the cryptography community to go from a world in which cryptography was basically you've got a single key and it's used for both reading and writing, to you have two keys, one key to read, one key to write, and those keys are separable. Right? The original work goes back to GCHQ, where somebody comes up with this notion of wouldn't it be amazing if we had a key, one key to encrypt or one key to decrypt, and then they spend years looking for an appropriate branch of mathematics that has that property, and finally stumble into computational complexity as the thing that will allow you to make this work. So it's easy to encrypt, it's hard to decrypt. If you know the secret, it becomes fast to decrypt because the mathematical operations are easier. And this is essentially at the heart of all of the stuff that you think of when you say crypto for redecentralization. You're all going to use asymmetric key, two-key cryptography in your systems, because unless you've got a pre-existing secret communication network, single key cryptography doesn't really buy you anything, right? Double key cryptography is where it's at, and the mind shift in the cryptographic community that went along with this can't be overstated. This was fire from heaven. What do you mean you use a different key to encrypt and decrypt? This will change everything. And surely enough, it doesn't, right? What happens is you basically get into this position where we get the technical possibility of doing something amazing, but society doesn't budge. It doesn't come along for the ride. Sorry, I had the wrong slide up. Now, when I say we thought the world would change, right? The rhetoric of the early cypherpunk movement is that asymmetric key cryptography will result in the collapse of the nation states, right? This is boldly stated by tons of people in the early 1990s. PGP will equal the end of government as we know it, and there's no way around that. And that claim is made with a perfectly straight face by people that are doing things like running branches of Intel. You go back and you look at like Tim May's Cyphernomicon, and the boldness of the claims made are that once you can reorganize society around this kind of cryptography, the state will become unable to function and everything will just fall to pieces, and there'll be the emergence of this new spontaneously organized, self-organizing anarchy that kind of automatically does the functions of society through spontaneous cooperation. Did that happen? Has anybody noticed that occurring? Because that's certainly not. And nobody's really clear about how things interface between technology and society. We keep expecting this kind of massive discontinuous to change, and it keeps just not arriving. So what we did was we got polarization. We got an enormous amount of force applied by the state to try and get this technology back under control. Right. In the early days of GPG, the US retaliated with an export control agreement, which meant that it was illegal to take public key cryptography out of America. You couldn't export the software legally. If you did, you were going to go to jail. So what we wound up doing was printing the source code into books, because books were covered by a different set of legislation, physically mailing them to Europe, then scanning it all back in again, correcting the errors, compiling the code, and having a European distribution of the code. Can you imagine being in an environment where the government has made software that people are writing and using to protect their privacy flat out illegal? And this was the situation that pertained to those things. And the feeling that this was a kind of revolutionary era, and that we were just one step away from 200 million PGP users blinding the US government and everybody running around doing what they liked in the resulting anarchy. This was a really hard, tangible thing that always seemed to be just around the corner. So, the next question was, how were we going to enable people to figure out which key went with which user? And this problem goes by the name of public key infrastructure. So the expectation was that you were going to build emergent social structures using cryptography. But these emergent social structures are impossible to build if you can't identify which user is attached to which key. So the classic instance of this is the man-in-the-middle attack, right? I want to send a message to Gav. I ask, Francis for Gav's key. Francis gives me Francis's key and says this is Gav's key. So I now send a message to Gav, and Francis reads it in the middle, then takes the message that I was going to send, encrypts it with what he knows to be Gav's key, and now we've got a silent intermediary who's stealing all of our data. And we went through an enormous amount of work attempting to figure out how to address the man-in-the-middle problem, and what came out of that was the so-called GPG Web of Trust. Right? The GPG Web of Trust is why nothing happened with cryptography in the 1990s. The Web of Trust is just a failed thing at every possible level. Nobody ever used it in any kind of disciplined way, and as a result, it was impossible to verify who keys went with. The fact that there was no generally usable public directory of people and their crypto keys is still completely anomalous, but nobody ever figured out how to do that, and as a result, we never had one. There were key servers and all the rest of this stuff, but it never fundamentally worked, because there was no way of pinning a key to a person other than this notion that lots of people who knew that that key belonged to me would sign the key, and then you could look at all their signatures, and you would know enough of them that you could probably figure out that if 15 people on that list were people who you knew the key for, then that key was probably trusted. And actually, what went along with that was a mindset that ordinary people found completely intolerable to think about. So the whole thing of keyring management and secrecy and trust networks and all the rest of that, to ordinary people, this was just mental pain that they could not live with, and as a result, they just didn't use PGP, and it almost entirely grounded in the key distribution problems. Because actually, getting your email to encrypt is really easy. You just push a little padlock button. The hard part is getting the key of the person to encrypt it to. And there's a name problem right in the heart of that, which is binding a human being to an email address and then binding an email address to a key. And because it's a two-link system, you wind up having to independently check each one of those links, and the result is just one level of indirection more than people are willing to handle. So GPG Web of Trust goes nowhere. What does succeed in a huge way is the X509 standard in the form of HTTPS certificates. So you hear all this stuff in the news now about certificate authorities falling to pieces and all the rest of that, but we actually got 15 years of highly usable civilian cryptography. It's just it was centralized cryptographic key management, assigning keys to institutions that came with a check. And then once you had that kind of network of keys established for Amazon and for Google and everybody else, ordinary users could trust anybody that was in the key management hierarchy. And this was essentially a straightforward bureaucratic deployment of cryptography that created a kind of bureaucratic regulated space that allowed civilian cryptography to work. But it wasn't peer-to-peer cryptography, so there was no real way in practice of using the security offered by the X509 hierarchy, the certificate hierarchy, for point-to-point communications. So if I wanted to send a message to somebody, their key was not in the X509 space because those certificates were for web access. They weren't reusable for email in any kind of normal fashion. So there was no way for me to attach myself to that pyramid so I could get secure communications and prove who I was. There was a ton of discussion about doing that kind of stuff, and companies started to try it, but in practice it never widely shipped. And as a result, what we were left with was a way of finding out which key goes with which person for companies, but no effective way of finding out which key goes with which person for people. And as a result, we wound up with no way of finding our way through the crypto space, and as a result, there was just no adoption. Now, these kind of problems, right? These are techno-social problems. They're woven between our understanding of technology and society, and in the middle is the psychology of usability and user comfort. Does anybody know of a thing called the mental accounting problem? Yep. So the mental accounting problem is why nobody's ever had a micropay standard that worked. Turns out that the mental kind of difficulty or the mental tax or overhead of deciding to spend 2 pence to read a web page is roughly the same as the mental overhead when you decide to spend £20 on buying a book. So if you've got tons and tons and tons and tons and tons of little microtransactions in your life, you constantly experience anxiety because you're constantly making spending decisions. And as a result, even if the amount of money that's being spent is the same £20, spending it 2 pence at a time feels like an enormous labour. And over and over again, every 10 15 years, people reinvent the idea that we're going to pay for our content with micropayments. The latest instance of this is people talking about how we're going to have streaming music where you pay by the minute. I just don't think that's going to work, right? We've got a long history of micropay and it just doesn't happen. Similarly with everything to do with cryptography, if the users can see the cryptography, the product will not get used, right? Long strings of hashes, weird looking addresses with 48 character identifiers and then weird signature blobs and all that. Never happen. Trust mechanisms that need me to actively think about whether or not the person I'm communicating with is who they say they are. Imagine that translated into the physical world, right? You meet somebody in an office and you have to examine their face really closely to make sure they're not wearing a Scooby-Doo rubber mask. Is that actually your face? I can't tell. And when you psychologically put people into that position, when they have to do something like validate a key, it creeps them out in exactly the same way that having to do like rubber mask checking would creep them out in the real world, right? We are primates. Our instincts are really not very well evolved for technology, and cryptographers are the tiny percentage of the population that find this stuff intuitive and easy to think about. So what's happening is because we've got a non-neurotypical community that does all the real work on this stuff, trying to export their ideas to the neurotypical community, what we have is an enormous hump of misunderstanding. And that hump of misunderstanding shows up all the way through all of these arenas, but it most specifically accretes around key management. And we never got HTTPS for all websites. Still, it's backwards and forwards. So all of that stuff pretty much stalls out in the late 1990s at the equilibrium of we've got HTTPS, aka X509, and nothing else really happens in cryptography basically for the next 10 years, right? In the margins, there's a whole bunch of R&D thinking that gets done. First piece of this is this thing called hash cache. I think there might have been hash cache implementations as early as, I want to say, in the late 90s. But really the hard thinking around this stuff doesn't happen until a bit later. Hash cache is simply the idea that I run my computer for a long time and I generate a proof that I did that, and then I use that proof to show somebody else that I've done a bunch of work. And the normal way of doing that is that you will ask me to prove something. So you give me a problem to solve, and it will take 40 hours of my computer's time to solve that problem. And when I hand you back the result of that, you know that I actually cared enough to put in the effort. If you're in some kinds of situations where you assume the person you're dealing with has limited computer resources, you give them a hard problem, you give somebody else a hard problem. If both of those problems get solved, you assume these are different people. And that kind of thinking doesn't really apply in a networked world, but it can apply in certain kinds of special cases where you substitute proof of work for proof of identity. And that sort of stuff kind of burbled away in academia. There were a couple of proposals for using hash cache as a way of preventing people spamming each other on the internet. So you've got to run your computer for 5 minutes before you can send an email, makes spamming impractical. But basically, nothing happens with hash cache. It just kind of sits there and burbles along for a while. Not much happens. Now, then we get the distributed hash table. So hash table, common data storage mechanism inside of computer programming languages. You take a key, which is something like a name, you take a chunk of data, which can be anything you like, and you've got a quick mechanism for going from looking at the key to getting the name. Common as dirt, all through computer languages. Decentralized hash table, same mechanism, but now you can store petabytes on the damn thing because it's fanned out over 10,000 computers. And again, comes out of academia. I think one of the early implementations is something like Camellia, and lots of interesting little projects kind of burble along, lots of these kind of, two guys and a dog on a string kind of little hacking projects, and then boom, BitTorrent. And BitTorrent is the first mass deployment new cryptography app that really happened since the invention of PGP. It's a really, really commonly used thing, everybody's using it, and it's kind of like the first kind of harbinger of what's to come. GPG, X509, BitTorrent. And BitTorrent also begins to broach this question of cryptoeconomics because it has an internal mechanism for tracking. You get so many chunks of file sent to you, you send so many chunks of file back out again, and these numbers are supposed to stay close to each other. So we begin to use a pseudo-economic model for validating that people are actually doing their share of the work required to operate the network. And again, this becomes quite important later on. It's the first inkling of a new way of doing things. So this is the part where we're beginning to get bite on a new idea. Bitcoin. So Bitcoin is really something that you've got to put into the historical context of 10 years of people hacking away on computers going to radically change society, right? Very libertarian, a lot of those folks, very anti-state. E-gold was a very commonly used cryptocurrency system among those people, not even actually a cryptocurrency, gold reserve backed account based. And slowly, this Bitcoin thing comes over the horizon. Like, well now, we've got people running their computers generating these coins. The coins can be transferred to each other. They float, they don't really have any value. The software is a bit buggy. Not much happens. 2011, 2012, boom, suddenly realized that the internet now has a central bank and people are making money. And I say making money in both senses, right? They're physically running their computers to generate coins, and the coins turn out to be worth dollars. And the immediate image in the heads of the general public that hear about this at this point is that people have basically turned their laptop into an ATM machine. They just keep pressing enter and $20 bills come out. Right? And at this point, we have something that people can really relate to. I'm gonna be rich. So what this starts is the stampede into Bitcoin. And Bitcoin is designed in such a way that the response that happens to a stampede is not that more Bitcoin is created, it's that the price of Bitcoin goes up. So early adopters of Bitcoin suddenly get rich, which is why you've got maybe $500 million or $1 billion of risk capital sloshing around in the Bitcoin ecosystem because it's all these folks that made out like bandits in the early days of Bitcoin. And the capitalization of a radical political group with actual financial assets who can then continue to write software to attempt to implement their political vision is one of the biggest historical turning points that we'll have seen since probably World War II, right? Once you've got a different power elite holding actual capital reserves, they can begin to create a new world without having to ask the say-so of people that already have access to capital. And that's a really new development. That's really something to watch. So, let's put the pieces, whoa, what happened there? So lost my last slide or two? What's happening? Can somebody come and take a look at this and try and figure out why it doesn't have my last slide? Should I just reload it or something?
Nothing else is fine.
Yeah, I guess. Okay. So, when I say combines all of these systems, right? Bitcoin has an architecture where all of the pre-existing sort of cryptography that we know pretty much winds up embedded inside of Bitcoin, right? The stuff about two-key cryptography, core to it because the addresses that you send money to or receive money from are keys. So all the key management stuff inside of Bitcoin, these are the accounts. Hashcash is used because it becomes mining. The DHT is used because it's where the data is stored. Right? Bitcoin is essentially a summary of everything that we knew about cryptography up to that point, all wrapped together into a single system. Not all the weird esoteric stuff, but the major algorithmic breakthroughs are all represented. And what happens is that we get actual social change because we've finally gotten a fundamentally new capability, and because it turns your computer into an ATM machine where you just press enter and money comes out, at least in the public imagination, people pile in and actually use the damn thing. And think of it in terms of generations of technology. GPG, theoretical, doesn't really go anywhere. X509, aka HTTPS, widely adopted. BitTorrent, widely adopted. Now, why is that happening, right? GPG, you can't actually transact value, but you can communicate. Okay. X509, HTTPS certificates allow you to use a credit card on the internet. Exchange of value is happening, trade is happening, people pile in. BitTorrent allows mass piracy of files more efficiently than before, and you don't get arrested. Amazing. Suddenly it gives you access to value, works very well. Bitcoin comes along, press enter, receive money. Allows access to value, allows transmission of value, allows people to get a ton of money made. So it seems like cryptography that allows trade turns out to have a pretty good history of actually getting built, but cryptography that doesn't allow trade doesn't. And I think that might be an interesting design principle for Redecentralize type projects. show how trade is going to be fueled by this thing. If it's going to allow people to sell their hand-knitted woolen socks to their neighbors more efficiently, maybe people will adopt. This brings us to Ethereum, right? So Ethereum comes along when people start looking at this here blockchain and saying, well, right now all it can store is transactions, and transactions are not inherently all that interesting. What happens if we take code and we put code in the blockchain and then we run the code in the blockchain, right? And at this point, you kind of are like, what? But it sort of kind of makes sense, right? If you think of an Excel table cell, equals 57, or equals a formula, or equals the output of a function which is written in Visual Basic. You go from a number to a formula in a kind of limited language to full programmability with loops and recursion and all the rest of them. So we go from a transaction, we kind of skip the formula part, and we go all the way to a programming language. So Ethereum takes all of this kind of blockchain-y stuff from Bitcoin, replaces it with an upgraded version, and then puts a scripting language right in the middle of that. What's interesting about that is both what it does and what it doesn't do. So we still don't have this PKI stuff. There must be, 50 Ethereum projects that are in some way related to helping figure out who is responsible for talking to a key. So that's all the kind of KYC, AML, anti-money laundering, know your customer banking interface stuff. Or the projects that are trying to attach attributes to a key. Here is my public phone number, that's my crypto key. If you look that key up in the database, you'll discover it belongs to somebody that has an excellent record of borrowing cars for Bitcoin and returning them freshly laundered. Right? So the ability to attach attributes to keys or attach persons to keys, we still don't have a really good answer for that, and the work on that is everywhere. It's obviously hugely important, but nobody's cracked it. Interesting. And we still don't have massive communication networks that are doing peer-to-peer encrypted comms using these things. So you would think that people would be routinely using their Bitcoin addresses as keys, which they could then use for, say, OTR messaging or PGP-style encrypted email or anything else like that. But in practice, the software hasn't been built out that will allow me to encrypt a message to the same address that I'm sending Bitcoin to. And this is another one of these peculiar things. Why do we not have a regime where it's relatively easy to use a Bitcoin address so that you know for sure that the message is only going to be read by the person that you're sending a payment to? And this is a curiosity. So what I'd like to end with is a little bit of analysis of what constitutes trade. You have two people, they want to do business together. They, generally speaking, if they're doing anything more complex than barter, need a medium of exchange. Typically, the medium of exchange is money, right? But the money is simply a metal disc whose physical appearance is essentially copyrighted by the state, right? If you make one of these for yourself, they call it counterfeiting, and they give you 20 years in the electric chair. So the metal disc only becomes a medium of exchange because of the external presence of the state guaranteeing that there will be a certain set of rules that apply to how these things are used. Right? You get along to cryptocurrencies, the rules that define how this stuff works are embedded in software, right? And you have a string on your computer that represents a transaction. You could copy that string, you can mutate it, you can XOR it with your birthday, whatever the heck you like. But the fact that it is as if it was money is created by this kind of external rule set that is shared by the society of people that are all running the Bitcoin client or the Ethereum client or a Litecoin client, wherever it happens to be. There's a social body that agrees on a rule set, but rather than agreeing by the rule set using a court system, they agree by assenting to be members of the system by running the software. But we've only really got mass deployment of currency and transactional instruments from those kind of agreements. What I'd like to see is some speculation about how we fundamentally solve the problem of citizenship within cryptographic entities, right? How do we get a conscious political bloc that says, right, we're the 85,000 people that are currently running a copy of this client, and collectively we act as a bloc to make decisions about how this thing will be administered. And this is actually quite an important problem because the enormous strife inside of the Bitcoin world about Bitcoin XT comes from the fact that ordinary Bitcoin users have no credible mechanism for political representation when they want to argue their case for one preference or another relative to the people that are writing the software. And I think that what we're going to find increasingly is that as the people who are standing behind these software systems are essentially making law for polities, we're going to need some mechanism of approximating democratic assent or democratic engagement relative to users and the people that are writing their cryptography. And I think that that is potentially the next large forward step in complexity as we've gone from generation after generation of systems that enable trade. I think the next jump is a system which enables a kind of digital citizenship. How do you become part of Wikipedia in such a way that you get to vote for the senior administrators that define reality inside of the system? How do you get to vote as a member of the Ethereum community on how funds will be allocated to do the next round of future development? Because I think that we've gone almost all the way to the end of the path, which is about transaction and trade, but I think the next step has to be governance. So.